Okay, I'm going to go over the fundamental theorem of algebra today. Once you can do these problems, you're good to go. So these are the ones that we're looking for. I'm going to start off with how to write a function given the roots. So, or the zeros. If I give you zeros of, let's just say 1, -1, and 2, what this means is that you can always write a factor as x minus the root, always. So if they give me these three, it's going to be x minus 1, x minus -1, and x minus 2. Of course, minus and negative is just plus, so I'm going to change that to plus. Now I'm just going to expand them one at a time. So I'm going to essentially FOIL these two together, which gives me x squared plus x minus 1. And I'm going to keep that in parentheses because I'm still going to have to multiply it by this x minus 2. I'm going to combine like terms first because that's going to make it more simple for me. And then I'm going to multiply this out. So I'm going to multiply everything in the first parentheses by everything in the second parentheses. In this particular case, it ends up I'm just FOILing, which gives me x to the third minus 2x squared minus x plus 2. This is my answer. This is the simplest form of a polynomial function with these as the zeros. So that's what I'm doing right here. The ones that are a little bit more complicated are when they give you information like this. This is a 0 and this is a 0. They've really given me 3 zeros here because you have to remember your complex conjugates, which the complex conjugate is going to tell me I also have a 0 of -4i. So don't forget that your complex conjugates are still going to come into play. It's going to be easier for me to multiply the imaginaries together first because that will eliminate the imaginary values. So I'm going to do that part first. And again, minus a negative is going to become a plus. So I'm going to do these two together first. X times both of those, -4i times both of those. So it's going to give me x squared plus 4xi minus 4xi minus 16i squared. These two are going to cancel out. And I squared is -1. So -16 times -1 is plus 16. I'm going to keep that in parentheses, and I'm going to bring down the x minus 2. Now I'm going to distribute this out, which is going to give me x to the third plus 16x minus 2x squared minus 32. And I want it in standard form, so I'm going to put x to the third minus 2x squared plus 16x minus 32. This rule is also going to be true when it gives me a square root. So if it tells me that my zeros are something like this, if it tells me my zeros are 2 plus 3i and the square root of 7, that means by the rule of complex conjugate, I also have 2 minus 3i. Remember that only the I changes sign, the 2 keeps the same sign. The square root of 7, whenever I have a square root, I have a positive and a negative square root. So that means I'm going to have the negative square root of 7 as well. So now I'm going to go through the process. X minus 2 plus 3i, x minus 2 minus 3i. I'm going to put these guys next to each other because it's going to be more simple. X minus the square root of 7, x plus the square root of 7. So I'm gonna distribute this guy out, x times all of these, which gives me x squared minus 2x minus 3xi, -2 times all of these, which gives me -2x plus 4 plus 6i, and 3i times all of these. So that's going to give me plus 3xi minus 6i minus 9i squared. I have minus 3xi and plus 3xi. Those cancel out. I have plus 6i and minus 6i. Those cancel out. So I'm going to have x squared, -2x, and -2x is going to become -4x. I squared is -1. -1 times 9 really just means plus 9. So plus 9 plus 4 is plus 13. I'm going to keep it in parentheses because I'm going to have to multiply it by the part that I get when I do x minus the square root of 7 times x plus the square root of 7. So I'm going to FOIL this out as well, which is going to give me x squared plus the square root of 7 times x minus the square root of 7 times x minus the square root of 49, which is 7. These two are going to cancel out, so that's going to leave me with x squared minus 7. And I'm going to put that in parentheses because that's going to have to get multiplied by this guy up here. So I bring this down, multiply everything in the first parentheses times everything in the second one. So that's going to give me x to the 4th, still on the screen, minus 4x to the 3rd plus 13x squared minus 7x squared plus 28x minus 91. I'm going to combine like terms. X to the 4th minus 4x to the 3rd plus 6x squared plus 28x minus 91. And that's my final answer right there. That's the simplest version of the polynomial that has those zeros that I started with. Now solve by finding the zeros. Those aren't too bad. What we're doing is we're just starting with a rule like this. And I want to factor it any way that I can. Since there's more than 4 terms and I can't factor the same thing out of everything, pretty much what I'm going to have to do is use the rational root theorem. So I'm going to look at my possible zeros. My possible zeros are all the factors of this, plus and minus on each one, divided by all the possible factors of this. Now luckily that one's just 1, so these are each over 1. And these would be plus and minus as well. Not that that really matters because I'm dividing anyways. So that really just means positive and negative 8, positive and negative 4, positive and negative 2, positive and negative 1. So I'm going to use synthetic division on this guy. I have a power of 4, 3, 2, 1, 0, so I don't have any zeros to put in there. I like to start with the little ones just because that's usually the easiest for me. So I'm going to start with 1. Remember, the first term always comes down, and then we multiply, we add, and we multiply. We add. Oh, I forgot how to add really fast. We multiply, we add, we multiply, and it gives us a remainder of 0. So if there is a remainder of 0, then the one that you just used is one of your zeros. So one of my zeros is x equals 1. That's one of my zeros. Now I'm going to put the variables back in. Remember that you start one less, and see if I can factor by grouping. So I'm going to factor by grouping by doing this right here. I can factor out an x squared, which leaves me x plus 2. I can factor out a 4, which leaves me x plus 2. So this becomes x squared plus 4 times x plus 2. I already know one of the zeros is 1. If I set these equal to 0, I'll get the other ones. So x plus 2 equals 0, subtract 2, and I get another 0 at x equals negative 2. For this guy, x squared plus 4, I can't factor it, so what I'm going to do is I'm going to use the quadratic. So this equals 0. The quadratic equation is going to just, well, I mean, for this one I could just subtract. That's probably what I'll do. It's easier. And then square root. Since it's negative, it's going to give me 2i and negative 2i. So all of my zeros are, and I'm going to put them in roster notation, 1, negative 2, 2i, negative 2i. And that's what we're looking for on these ones. So essentially the fundamental theorem of algebra tells us that whatever the degree is, that's how many roots you're going to have, or zeros, including repeats. So sometimes you have a repeat. This time we didn't have any repeats. We had 4 different ones. But sometimes you can have repeats, and that's okay. So this is our answer, okay?